This is a very important part of what we do here with pre-calc and trigonometry in particular. We're going to look at angles and their measure today and really delve into some of the things we talked about previously in regards to radians and degrees and how we apply those. So, first of all, we need to talk about what a ray is. It's a half line. It's that portion of a line that starts at a point V on the line and extends indefinitely in one direction. It's kind of common sense, right? The point is called the vertex, okay? The point of that half line or ray. Now, if we draw two lines from that common vertex, they form what we call an angle. Obviously, you're wondering why are we talking about this? This is too easy. Well, this is where it gets a little more complex. One of the rays of an angle is called the initial side, and the other is called the terminal side. So if I'm going to make this angle alpha, I start with an initial side, and I always go counterclockwise, unless I'm told otherwise. So a positive angle is always counterclockwise, always. A negative angle is clockwise, okay? So there is a clockwise rotation of beta. Start at the initial, go to the terminal. And I wanted you to see something. Beta and alpha are two different angles, but you end up with the same place, okay? Now we could also go gamma. That is a positive angle as well, but we go around counterclockwise once, plus another however far, that was alpha, wasn't it? So that's interesting. Not used to doing that for sure. Now, an angle theta, this is THETA. Get used to seeing that. We represent angles with Greek letters in mathematics. And theta, alpha, gamma, and beta are probably the four most commonly used ones. You'll see phi once in a while, trying to think of others. That's basically about it. Anyway, this angle theta is said to be in standard position if the vertex is at the origin of a rectangular coordinate system and its initial side coincides with the positive x-axis. So this angle right here is what we call standard position. Remember, initial means where we begin, terminal's where we end. When an angle theta is in standard position, the terminal side will either lie in a quadrant or it'll lie on the x or y axis. Those types of angles are called quadrantal angles. Quadrants, you see the word quadrant in there. Quadrantal angle means 90, 180, 270, or 0. Okay? So theta is not quadrantal. It's going clockwise, so this is a negative angle. That is in quadrant 3. Remember, it goes 1, 2, 3, 4. Remember your quadrants from algebra. It's the same concept. Okay? Theta here, though, is a quadrantal angle, and I know you know it's 180, but it's actually negative 180 because we went clockwise. Okay? To be counterclockwise, that would be a positive 180. Okay, so there's the difference, but that's called a quadrantal angle. Okay, now, this is going to be cool, I think. I showed you that geometry sketchpad on Wednesday, last C-Day, of what a radian is. And radians are just a simple way to measure angles. I think they did it was formed because of calculus. And I don't know the historical reference, I'll have to look again. But it has something to do with the fact that it's much easier to calculate with radians than it is with degrees. And you're going to find that out as well. Okay? So let's start this then. First of all, degrees. 1 degree is 1/360th of a revolution. Think about it. Protractor is 180 because it's halfway around. We break that into 180 degrees. And why, I don't know. I don't know why we use 360. I would guess that it was because of travel along the sea or at sea, and they use a sextant, which they used ratios of 6, I believe. So that's why they probably broke it down into 360 degrees, I'm guessing. Not for sure, but that's what I would predict there. Okay, a right angle obviously is a quarter rotation, quarter revolution. That's 90 degrees. A straight angle is 180, or half a revolution. Now, I went ahead and drew this already. This was a mistake, sorry. Draw a negative 135 degree angle. Well, this is 90 right here. Then halfway is 45, that's 135. So that's how we would draw a negative 135 degree angle. So what if I said, 30 degrees? Well, you always start, 0 is always at 3 o'clock, okay? We're gonna estimate that 30 is about right there. We write 30 degrees in there, it is 30 then, okay? It's just rough, we're guessing. How about negative 240? Where would that be? Well, that's 180. Another 60 would put us there. That's close. We'll go with it. It's hard to draw with this pen. I know I'm making excuses, right? I can't draw anyway, but that'll work. So that's how we use the initial side and the terminal side to draw angles. Now, I showed you before that when we make a circle, any circle, if we measure the radius right here, let's say we take a piece of licorice and we roll it out, that piece of licorice along the edge of the circle, the circumference of the circle, that angle right there we call 1 radian. Now that is not a measure of distance. It is actually the measure of an angle in radians, okay? And if you recall, it takes 2 pi to go all the way around, or around 6.28 radians, okay? And we talked about that with the Sketchpad activity there the other day. Okay, so 1 revolution is 2 pi radians. So 180 is pi radians. So 1 degree is pi 1/80th of a radian, and 1 radian is 180 over pi degrees. Now I'll show you how to use those, but when you get a chance next time, look at the wall to my north, the wall on my north side of my room, and there is a board up there, and you've probably looked at it wondering what those pi's are. Pi over 6, pi over 4, pi over 3. Well, that's exactly what they are. Pi means 180 degrees. So when you see pi over 4, well, what's 180 divided by 4? Oh, 45 degrees. So those mean the same thing. Those are equivalent. So when you see pi over 3, 180 divided by 3 is 60. So that's 60 degrees. 2 pi over 3 is 120 because there's 2 of them. And we'll get into that as we go through more and more. We fill out our unit circle and really start to understand what radians are. So if we're going to convert 135 degrees to radians, okay. You probably did this in chemistry last year. Maybe I doubt you had physics, but in chemistry, I know you do conversions. So we're going to take and convert degrees to radians. So radians has to go on top, degrees goes on bottom. Well, there is our pi radians in 180 degrees. Because now your degrees cancel, and now you got 135 pi over 180. Now I don't like that, and you don't either. Now what goes in evenly to those? 45. 45 goes in there 4 times, 3 times, it's 3 pi over 4. So you're always looking to simplify, okay? Let's get some more here. How about, let me think, how about 250 degrees? Now that's not a good one. So pi over 180, right? And then start canceling. Well, your zeros cancel. Now does anything go into 25 and 18? Nope. And we always want to keep it exact. Don't use decimals on radians. So it's about 25 pi over 18 radians. What about 300 degrees? Well, pi over 180. Okay, put that over 1. Your zeros and degree cancel. So now you have 30 and 18. 6 goes in there 3 times and 5 times. Multiply straight across. It's 5 pi over 3. You will have these memorized. Trust me. Number 1, you'll have a test over it. Number 2, you have to have it memorized just to make things easier for yourself. Okay, now we're going to go the other way. If converting degrees to radians was pi over 180, to convert radians to degrees is going to be 180 over pi, because we need the degree in the numerator. Okay, now you can start canceling. Pi goes into pi, 3 goes into 180 60 times, negative 120. So it's negative 2 pi over 3 is negative 120 degrees. So let's say I got 7 pi over 4. Well, you're going to multiply by 180 over pi. Pi's cancel. 4 goes into 180 45 times. No, that's not right. Yes. Yes, that's right. So we got 45 times 7. So that's 35. It's 315 degrees. Okay, so that's how we convert from radians to degrees. Now this is really fun, and this is where you want to use your calculator. All right. 1 minute denoted by 1 minute, apostrophe, is defined as 1/60th of a degree. 1 second, denoted as 1 quotation marks, is defined as 1 over 60th seconds, or 1/3600th of a degree. Now, what is the purpose of dividing a degree into a minute and then minutes into 60 seconds? Well, think about sea travel. If you are off by 1 degree at sea, where do you think you're going to end up on a globe, right? And you're sailing for a week. I mean, you're going to be way off. So therefore, they had to break the degree down into minutes, 60 of them, and then they broke those down into 60 seconds. And then 1 counterclockwise revolution is 360 degrees. 60 minutes is 1 degree. 60 seconds is 1 minute. Now, how do we convert 30 degrees, 12 minutes, 55 seconds to a decimal in degrees? Okay, take your calculator. This is about the easiest thing we can do. So all we're going to do is we're going to type in 30 and then second angle, which is apps. Second apps. Hit enter. And it says on your calculator 30 degrees. Second apps. And there's your angle button. It says angle on it. Okay? 30 degrees. Then you're going to go, let's see, what was it, 12? Then type in 12. Now you need that little apostrophe. Second angle again. Second apps. That's number 2. Hit enter. So your calculator reads 30 degrees, 12 minutes. Now we need 55 seconds. Now slow your water here. Seconds is quotation marks, which are in, on my calculator, they're in green. And those are located, I believe, above the plus sign. And it's going to be alpha plus. So you're going to type in 55 alpha plus. Alpha plus key. Okay? And you should get that. Now when you hit enter, it converts it to degrees. And it doesn't say how many decimal places to go. So I'll go 5. 30.21528 degrees. Now you do not want to see how to do this the long way. Okay, let's go 65 degrees, 14 minutes, and 5 seconds. So do that quick. Remember, second angle is where you're going to find degrees and minutes. And then seconds is going to be found in alpha plus. I got 65.235 degrees. Okay, so that's how we use our calculator to convert from degree minutes seconds into decimals. And by the way, it's DMS. Now you talk about easy. To do 45.413 degrees to DMS form, you simply type in 45.413, hit second apps again, second angle, and go down to number 4, which says DMS, and hit enter. And I got 45 degrees, 24 minutes, 46.8 seconds. So that's the DMS key, second angle number 4, after you type in the decimal in degrees. So that's just kind of a fun little thing, little lesson. Okay, and that's it for our first part of our introduction to trigonometry. Make sure you do the first worksheet.